I actually came across a very interesting article by Ruskin Bond. This article by Ruskin Bond, he remembers his less cash days. And he remembers that there are certain pleasures one can only have if you have less cash with you. Inspired by that, I have this why I miss my less power days. And this power refers to electrical power. So I have been educated in different parts of the country and the world. And for some years of my school education, I was in Assam. In the remote distance, these hills are Meghalaya. My school was in Meghalaya. I could see my school on clear days. When there was a power cut, no power for next 20, 30, 50 kilometers, anywhere, any distance you can imagine. No home had any power. And at that time, the entire sky at night descended on you. You could see so many stars that one can't imagine to see them in the city. I believe the kind of place your college is in, you might also be having occasions where you can see plenty of stars, plenty of planets. And so this less power days was a boon in some ways that I could, because I had a telescope at hand and I could explore the sky. And it was the right age for me to get introduced to some of the wonders of the universe. I was in class 8th at the time. And this observation says that this is about the Cassiopeia constellation on 23rd November 1992. It gives the what is the position of this constellation in the sky, and the time is 6:30 p.m. And in the next slide, I have something interesting. So I have this map of this constellation, and I had star maps with me. So from that, I constructed this. And these star maps not only provided to me the constellation stars, but also some other faint stars which are visible. And a very interesting remark I had made 30 years ago, in this figure, this star marked as AZ is not marked in any map. I have neither seen it any time before, and its magnitude is above 4. It's clearly visible to the naked eye. Now, it could be a nova or a comet, maybe a naive comment, because I was just getting introduced to astronomy, and I discovered something which is not on the map. Whether it was something significant or not, I do not know. But at that time, I got really fascinated that I have made a discovery as a student, and here is a star which is not there on the maps. I have found it. So there is this very popular movie, E.T., where you talk of the alien in the backyard. And now you're looking at stars, planets, and you get all kinds of ideas when you watch such movies. So that's how things were very fascinating. And there's this very nice book from Mir Publishers, Space Adventures in Your Home. So I had this book with me during my school days, and I used to try out some of those experiments mentioned in this. So later on, I ventured to doing a PhD in physics, condensed matter physics or solid state physics, nanotechnology, quantum mechanics, and then a postdoc in those areas. Somehow my interest in astronomy got left behind until a few years back it got revived again, and this is how that happened. So this is my daughter, and she was studying in her school about various kinds of planets or various celestial objects, planets and stars. And so there is a picture book in front of her. It's class 1 or 2, and there are different planets shown here, their orbits, and she was asking me many questions. So I thought, why not pick out the telescope that I had from my childhood time, and that you can see at the background, and try to show her something. So the first object we focused on, and this is the first picture I took after a long gap of some 20-25 years. All that time the telescope was locked up. I was busy doing research and other things. Now I got the chance, let's look at the sky again. So although I thought this would be a planet, but it turned out to be the brightest star in the sky. And as you might know, this is the star called as Sirius. It's the brightest star in the sky, Sirius. In fact, this brightest star is also interesting for one more reason. There are a pair of stars, Sirius A and Sirius B, and you can only see Sirius A, and that is the brightest star in the sky. If you have a better telescope than the one that I was having, then the kind of picture you would see from that telescope looks as follows. This is Sirius A, and very close to it, it might just appear like a speck of dust on your screen. You won't be able to see it. There is a tiny, tiny another star, which is Sirius B. And together, these are a binary star. A much better picture has been taken by the Hubble telescope, which is shown here. So this is Sirius A, and you can see Sirius B to the lower left here. What is a binary star? In fact, one of the stars is Sirius A is just like our sun. Sirius B is a star which is having a large amount of mass, but it's extremely tiny. It's called a white dwarf. So I'll show you a little more about this. How did people come to know that there are two stars? In fact, they came to know about two stars without seeing the other one. So around 1860s or 1870s, one astronomer was observing the motion of Sirius through the constellations or with reference to the fixed stars. Now, Sirius is also a fixed star. It should not be moving. But then it undergoes this, what is called as a braided motion. So this is the position of Sirius A in 1900, then in 1910, 1920. So as it goes around, over years and decades, it completes one orbit. And actually what you have is the Sirius A and Sirius B are orbiting each other. Sirius B is not seen. Sirius A can be seen. The other partner, which is called Sirius B, which cannot be seen, is a white dwarf, and it's extremely heavy. To give an idea how heavy this is, if you take one teaspoonful of matter from this white dwarf, and which is shown here, it would have the same weight as an elephant. That gives an idea how compact this is. Matter is really packed very densely. And the idea behind dense packing of matter has to do with what is called as degeneracy pressure. After my daughter got interested in this, and I also revived my interest from my childhood, then we thought the telescope we have is not good enough. So we went for this Celestron telescope, which is shown here. And I'll show you some things that we observed using this. So this is a picture of Mars, and what I have done is I have a attachment for a cell phone. So this is a Newtonian reflecting telescope, unlike the previous one, which was a refracting telescope. So for this reflecting telescope, at the eyepiece, instead of looking inside with your eye, you can attach a mobile phone and you can take pictures. And so all the pictures that I will show you are from that mobile phone. And the one you can see here is that of Mars. A little zoomed in version is shown on the right. And you could see a faint reddish tinge for Mars. Everyone knows that Mars is a red planet. And the reason being that the surface has a lot of iron oxide and other chemicals and compounds which have a reddish tinge associated with them. It's also possible to see the polar caps which contain ice. Both the North Pole and the South Pole of Mars have ice. Although the company advertises that it is possible, I have not yet been able to see it. Maybe I need to drive out of Chennai to some place where the sky is more clear, or some place like the hills of Kerala where it's possible to see things with better resolution. So I'll tell you a few interesting stories and facts about Mars, some of which you may know, some of which you might not. And while I was taking this picture of Mars, my daughter took my cell phone and took a photograph of Mars. I was not aware. And she wrote there, Mars planet. I have also taken a photograph just like you are taking a photograph. And here she has put an arrow. This object here in the center is the Mars planet. So here is one very interesting story about Mars. In fact, Mars has always been fascinating for people because they have associated it with possibility of life. And there is one novel by H.G. Wells, which is called as War of the Worlds. In that novel, he talks about people from Mars or aliens from Mars. They descend on the Earth and they start attacking and destroying things. A very interesting incident happened, which is captured in this news item, New York Times of 1938, October 31st, 1938. This entire novel of H.G. Wells, War of the Worlds, was broadcast as a radio program on that day. And it contained a news bulletin which said that there has been an attack in New York, and the people from Mars or the aliens from Mars are attacking the human beings. And hundreds and thousands of people in US actually took it for real. Some of them attempted suicide, some of them went and hid somewhere, some took out a gun to be ready to fight. It's remembered as the first incidents where a fake news, and this was not planned as a fake news, but it turned out to be a fake news, or where electronic media caused mass panic in the public. It had a very deep impact on the public. It's also a research topic where how media can influence people. And so this was related to the story behind Martians attacking human beings. You could read about this also in this book, which is shown on the left, Broadcast Hysteria, War of the Worlds and the Art of Fake News. But is there really life on Mars? So that is a question to answer which NASA has been sending many space missions. India has also sent a space mission to orbit around Mars, the Mangalyaan. And the reason is that there is some methane on the surface of Mars whose origin is not very clear. So there are various hypotheses, although there is a rover on Mars which can pick up things, and even there is a plan to send those things back to the Earth for analysis. But the rover cannot probe, or currently the rover that is there cannot probe the things which are below the surface of Mars. And people have expressed a possibility that maybe the methane originates from some microbes which are below the surface of the planet. These microbes, through their respiration process, or they're unknown actually, so they might be producing some methane, but that's not a definite possibility. There could also be some rocks which combine with water to produce methane. And then there is a possibility that this methane gets stored in clathrate cages. So these are molecules which can hold the methane molecule and slowly gets outgassed, as shown here. And then it forms other compounds, say in the presence of ultraviolet radiation. It could also form carbon dioxide, which has been seen on the surface of Mars. So the reason why people explore life on Mars is through some such route. The methane and carbon dioxide seen there might have origin from real life which is below the surface of Mars. Unanswered question, but maybe decades along the line people might answer this. However, another interesting thing to note is all these space missions are causing what is called as a forward contamination. You take a mission from Earth to Mars or to the Moon, and even if you have the best of clean rooms where all this equipment is prepared, the rovers are prepared, even the best of clean rooms have some bugs. What I mean by bugs are viruses and bacteria, fungus, and the hardiest ones are going to survive. This is because in a clean room, you already create conditions where nothing can survive. But people looked up clean rooms and found out that some very, very hardy bugs can actually be there, and they will get transported from the Earth to the Mars. And once they are there, they begin to colonize it. So this is called as forward contamination. Starting from the Earth, you introduce some microbial forms of life on the surface of Mars. And it's an evolutionary selection process which has been accelerated. In evolutionary selection process, you have the hardiest survives. It goes through a lot of procedures or evolution changes, and then it reaches the form which is the hardiest. But here that selection is being done in the clean room. The clean room can only allow those bugs which are the hardiest, those bacteria and those viruses which are the hardiest, and they immediately get transported across this distance to Mars. The process is quite similar to how a disease is spread on the earth. If you take COVID-19, it happened, some part of the globe immediately happened on another part of the globe, all over the world. People also remember about smallpox, which got spread in North America when blankets were distributed to the indigenous Americans, the native Indians. So in a similar way, we are spreading some form of life on Mars through these planetary missions. Now I come to the moon, which is actually the brightest object in the sky. And this is a picture I have taken with low resolution. I'll show you one with the higher resolution. The moon has also very interesting features. You can focus on some regions. You can see mountain ranges, craters. You can mark spots. For instance, the spot marked here is called the Sea of Tranquility. And that is the location where Apollo 11 landed. Apollo 11 carried Neil Armstrong. It landed there in July 1969. You cannot see anything associated with that landing at all. It's too small to see. All you can see is the kind of crater or regions where they had descended. They are already marked in moon maps which are available. You can compare and you can see where actually they had landed. This is a zoomed in picture of one surface of the moon, which I took with my telescope, and here you can clearly see craters and other kind of deformed surface at one corner of the moon when it was in half moon stage. So that's why on this left side you don't have light, but this side is illuminated and you can see craters, especially the ones, these two are very clear. Now I'll tell you another interesting story about the moon, and this has to do with the work of this former NASA chief, Roger Launius. He had actually visited IIT Madras to give a talk, and this picture is from that talk. He has also written a book called Apollo's Legacy. So there you might have come across many people questioning whether this moon landing ever happened, for the reason that the only country which has gone to the moon is the US, and it has made multiple missions, the Apollo missions. No other country has made manned missions to the moon. Unmanned missions, many of them, plenty of them. But manned mission has only been done by the NASA or by US. Now, so many years have gone past. The Apollo missions have stopped. The first mission was 1969, and after that there were several missions. Since last several decades, no mission has gone. And he assessed that something that has become old, what do people perceive? And very interesting findings. Some few decades back, only a small fraction of people, like 6% of the people, were doubting it. 94% of the people believed it because there was such robust proof. NASA has put out so much evidence that there has been a moon landing. But what he found disturbing, that among the young generation of people living in UK and US, a very large fraction, 20 to 25% today, have doubts whether this ever happened. And the reasons that these doubts are amplified is that you can't use an Earth telescope to discover anything about it. You need to either travel to the moon or come to the moon's orbit in order to take pictures of the trail left behind by different people who went there, like Neil Armstrong went there. His walking trail is still there. Various objects that they left there can still be seen, but they can't be seen from the Earth. The most powerful telescope on Earth can have a resolution of 130 meters distance on the moon, whereas to see the objects which the Apollo missions left there, you need a resolution of 4.5 meters. So there's a vast difference, and unless you are on the orbit of the moon or on the moon, you can't see these things. But this has been confirmed multiple times by NASA and also by third party, that is by other space agencies such as the Agency of China or India. They have also confirmed this. This is a very important moment when Neil Armstrong landed on the moon, and the famous quote is known by everyone: "One small step for man, one large leap for mankind." It was probably the biggest technological achievement of mankind to send a person there and bring him back. The amount of money that was invested here has also been criticized. So there are both sides of it. A lot of people have said that instead of this, they could have provided quality education, healthcare. So much money went into just one mission. On the other hand, there are other people who say that this is a great achievement of mankind. So I'm not taking sides, but there is a very nice plaque which was left behind by Neil Armstrong. And they did not say that America conquered the moon, although this was a product of the Cold War between Russia and America, who will be the first person to be on the moon. America was the first and the only country. But the plaque that they left behind reads the following. Here, men from planet Earth first set upon moon July 1969. We came in peace for all mankind. And that's the spirit with which science should be pursued. Science is a global effort. All countries, all people are involved in it. And we have to take it forward together. Developments happening in one country help us. Similarly, the work done in India helps the work done in another country. When you look at journal publications which happen, the research which is done, there's a lot of cross communication. Nobody can work in isolation. So really this message that they left behind on the moon, and which is still sitting as a plaque, a stainless steel plaque which is left on the moon, reads, "We came in peace for all mankind." That's the spirit with which science should be pursued. So let me go on to other things in the sky. And in this photograph, you could see next to the moon another bright object, and that's the evening star called as Venus. It's also called the morning star and the evening star. So I'll tell you some things about Venus. Now, how do I go about focusing this? So here, what I do is I take my reflecting telescope, I focus it on some distant trees, leaves of those trees. So you could see that these trees are now in focus. That means it is able to see large distance, and now I can focus on stars or planets or moon, whatever is interesting. And I started to focus on Venus for the first time. So it was really a shock to me, because I have been pursuing astronomy for quite some time as a side interest, and I had never seen what I'm going to show you. So you could see something in the corner. It's not so clear. And when I really took a zoomed image, it surprised me, because Venus was looking like the moon. It was in a crescent phase. And I initially wondered, is there something obstructing the lens? Why is the Venus not completely visible? Why am I seeing only some part of it? And later I learned, and as I'm going to show you, that this discovery of different phases of Venus is very central to the work of Galileo. I'll just show about this in the subsequent slides. The ancients probably, we are not convinced, but they probably had seen the Venus as the crescent phase of the Venus with their naked eye. So why do they say that? In Mesopotamia, ancient Mesopotamia, there is the following literature which reads, if on the right horn of Venus a star is visible, this crescent phase has two horns, just like horns of a buffalo or a cow. So if on the right horn of Venus a star is visible, as seen here, you will have good crops in the land. That's the proclamation made in this ancient text from Mesopotamia, several thousand years old. Then on the right horn of Venus, if a star is not visible, then the land will bear many misfortunes. So this author set out to say, discover whether these horns of Venus that are being referred to in this passage, are they talking about the crescent phase of Venus? Did the ancients know about it? Because until Galileo found it, nobody knew about it. At least in literature, nobody talks about it. And he concludes that there is a possibility, maybe the air was clear, or the eye power of those people was a little better. And I myself did some calculations which are shown here. So your resolution of the human eye is 1 arc minute, and that is about 3 × 10⁻⁴ radians. That means if a small object which is subtending such an angle 3 × 10⁻⁴ radians, is there, that's at the limit of your eye to be able to see it. And what's the angle that this planet subtends? Venus subtends an angle of 3 into 10 to the minus 4, exactly the same angle when it is at the inferior conjunction. Now, what's the inferior conjunction? When it is exactly between the Earth and the Sun. If you have Venus in between that, that's the closest distance you can have. At that closest distance, the resolution of the human eye matches the angular size of Venus. Anywhere else, it is farther away. So it's a matter of touch and go. If you really have a very good eye, the air is very clear, you might be able to see it. So I'll tell you this very interesting story about Venus, but to do that, I will have to just bring you to what the ancients were thinking about and how Galileo's observation of Venus really changed everything. So think about the time of Aryabhat. The view at that time was also that Earth is at the center and things go around it. But Aryabhat made a very important contribution. What he found out was that the motion is relative. And he writes in this text that just like you are rowing in a boat and you see some objects on the shore, those objects are stationary, but you see them moving. In the same way, we see the rising and setting of stars. The stars appear to move in the dome above the Earth. And this, he said, is because the Earth is actually moving, and this is causing them to appear as the stars are moving. So although the model was still geocentric, but he had some idea that there is a rotation of the Earth which is happening, which is presented in this paragraph. Now I'll talk about Galileo, who is the poster boy of all modern science. So many people attribute the Renaissance period or the beginning part of modern science, modern physics to Galileo. So it's good to spend some time on exactly what made him draw the conclusions that he is so famous for. Before him, the model which was due to Aristotle or Ptolemy was the geocentric model, the Earth at the center and all of these celestial objects go around it. Now, if you follow the motion of any planet, it goes in different constellations. Say in the month of March, it is in one constellation. After a few months, it's in another constellation. So how do you account for that? So what he did is Ptolemy brought in what is called as the epicycle. So there is this large orbit of this planet around the Earth, but that's not enough because the position of this orbit, the planet changes with reference to constellations. And so he brought in what is called an epicycle. That is shown here. Not only one epicycle, epicycle inside epicycle. So they went on adding this until they could correctly explain. The results were never wrong. The predictions were very accurate. But the model was very complex. An orbit inside an orbit, and then another orbit inside that orbit. So the process is called adding epicycles. One of the things that we know today, and I have drawn this cartoon to illustrate to you, is called as a apparent retrograde motion. So imagine you have the Earth going around the Sun as we know today, and the Mars also going around the Sun. Then for some moments, Mars may appear to go ahead in the constellation. But when the Earth is, say, at these positions and Mars is moving slowly, you might find that the position of Mars is slipping behind. It's going back. And that's called the apparent retrograde motion, the motion of Mars seen through the constellations as viewed from the Earth. And because both are moving. To account for all that, Ptolemy had in their geocentric model with the Earth at the center, all kinds of complex epicycles, which you can see in this picture, orbits inside orbits, everything neatly explained. There were some glaring mistakes which nobody pointed out. One of the things that we realize today, Ptolemy's model predicts that the size of the moon should be changing. Some days it should be bigger in the sky, some days it should be smaller. It should happen that way, but it does not happen that way. So the model was obviously wrong, but nobody found this error that the size of the moon should have been changing. It does not happen. So there's something wrong with Ptolemy's model. So how did Galileo find this heliocentric model? You can have a look at the phases of Venus. I was showing you the crescent phase. Now, if you are in the Ptolemaic system, the source of light is the sun, which is further away, and then you have the Venus, but the Venus is executing an epicycle and both are going around the Earth. So in that situation, with the illumination from one side, Venus can only be in the crescent phase. You can never observe any other phase. I can try to show you with an example with a torchlight if this represents the sun. And to do that, I'll just stop presenting for a while and let's see if I'm able to show this. Imagine this is the sun and you have Venus. So you can see that only the corners are illuminated. And if it is executing an orbit around the Earth, whereas I am the Earth, so you can see always the edges will be illuminated. On the other hand, if it is going around the sun, then it's possible to get a phase which looks like this. And this is the half phase. The half phase is only possible if such an illumination can happen. And this is also shown. I'll get back to my presentation. Please let me know once it is visible again.
Yes, sir, it's visible.
Okay, thank you. So you can see from this that in the Ptolemaic system, only the crescent phase is possible. Whereas in the Copernican system with the sun as a center and all these things going around it, you should be able to see the half phase, crescent phase, and indeed Venus has all these phases. I've shown you only the crescent phase. I'm still waiting to take a good picture of the other phases. So here is a nice story. When Galileo saw the crescent phase and he understood how objects are illuminated, there is competition between scientists in that era, in today's era. No, people always feel I should get the credit for this discovery. So Galileo was not so sure, but he also didn't want to lose out. So he wrote an anagram. It goes by the name of Galileo's anagram. It's in Latin. So I don't know Latin. I'll try to pronounce what is written. He cimature ame ian frustra lejuntur ovai, which translated reads, "These are presently too young to be read by me." He sent it out to all his friends, but did not explain what it means. Then he continued observing, and he was mainly afraid of Kepler because Kepler was giving him a lot of competition with the kind of discoveries both of them were making. He was afraid that Kepler might find this out before I do. And what was it? He waited for 6 months or some long period of time until he saw the half phase. He had seen the crescent phase. He had not seen the half phase. Once he saw both of them, he was convinced that the heliocentric model is correct. And then he unjumbled this anagram. He thought that if Kepler discovers it first, he will anyway unjumble it. But Kepler did not discover it. So now, having convinced himself and others that this discovery is establishing the heliocentric model, he unjumbled that anagram, and that reads Cynthia figura emulator mater emorum, which translated from Latin reads, "The mother of love, which is Venus, imitates the shapes of Cynthia, the moon." That is, Venus imitates the shape of the moon. Just like the moon goes through the crescent, half, and gibbous phase, Venus also goes through these phases. And that is why all these planets should be seen as orbiting the sun. Now, you might say that Ptolemy's model is something obsolete. Is there anything important about it? It is able to correctly predict things, and even modern day planetariums, they use a projector which is based on Ptolemy's model. The end result is the same. Ptolemy's model is not simple to understand, but you have things moving in orbits, epicycles, cycles within cycles. So the motion of gears and motors in a projector in the planetarium is frequently based on what Ptolemy had made for planetary motion. So that's one place where it has some relevance even to this day. So I'll come to another planet, and before I show that to you, another picture from my daughter's plan. She had some school project and she made a plan by herself, and she said, I have to make the solar system and this is a list of things, why don't you buy it for me? It had things like PVC pipe, electric wire, batteries, and then it had 14 balls. So I asked her, why you need 14 balls for solar system? You only need 9. For the 9 planets, and maybe 10 if you include the sun. So she corrected me that now the number of planets is not 9, it has become 8 because Pluto has been dropped. So okay, so 8 plus 1, 9. So why do you need 14? So it so happened that she had been observing me taking these pictures of different stars and planets, that she found out that Jupiter has 4 moons apart from our own moon. So then she counted 8 planets, sun making it 9, our moon makes it 10, and the 4 moons of Jupiter make it 14. I'll show you the pictures of the 4 moons of Jupiter, which I have taken. During the lockdown period, I got lots of time to take pictures of the sky. So this is Jupiter in the center, and you could see 4 of its moons very close to it: Europa, Ganymede, and Io. And this is also very central to the idea that Galileo had. I mean, this is the second reason. The one reason was the phases of Venus. The other reason was the moons of Jupiter. Because here in the sky was another object, Jupiter, around which other celestial bodies were going. Until that time, people believed that all celestial bodies, the moon, the planets, the sun, the stars, all went around the Earth. But then here is another planet, Jupiter, which has its moon. So there are celestial bodies which go around different other celestial bodies. So this did not really establish the heliocentric model, but it sort of demolished the geocentric model that everything need not have to go around the Earth only. And here are pictures from 1610, the diary of Galileo. He has taken the positions of these 4 objects, these 4 planets. Now, they could have been stars. They could have been stars which are very close to this planet. So on different days, you can see their positions. For instance, on 7th January, you can see only 2 of them because 2 of them are behind Jupiter. They are orbiting it very rapidly. On 8th, you could see 3 of them, and so on. And he has been on some days, he saw all 4 of them, just like I have seen. From this, he could conclude that these are objects which are orbiting Jupiter, and what kind of orbits they have, what is the kind of, which is the closest one, which is further away. He found out all these details. So this is another very interesting object you can see in the sky, the Jupiter with its 4 moons. So I come to the other interesting thing, Saturn. And this image is slightly blurry in the sense the rings of Saturn and the central ball have got merged. I have not been able to get a better image. But the interesting fact is, when Galileo first saw Saturn, he had seen the moons of Jupiter. He did not interpret that Saturn had any rings. And there is a very interesting reason behind it. In fact, he got totally confused. He thought that these are also satellites of Saturn, just like Jupiter had satellites. And they are orbiting, but the picture was always blurry. In fact, much more blurry than the picture that I'm showing you. The reasons for that are the following. As you can see from these set of pictures taken by Hubble telescope, Saturn goes through many phases where the position of the ring continuously keeps changing. You can see in the lowermost, the ring is almost equatorial. But if you go to the topmost image, you can actually see a slanted image of the ring. This is something that I've personally seen. I remember in the 1990s when I was observing Saturn with the small telescope I had in Guwahati in Assam during those less power days. I distinctly remember that the ring of Saturn was very different from the one that I have just shown you in the previous picture. So over a period of decades, these changes happen, or maybe over a period of 6 to 12 years, it goes through this cycle and then comes back. So when Galileo observed this over a period of 6 to 10 years, and the pictures were not so good, he was unable to conclude what they are. Maybe they are planets, but they are just changing position. So it's not clear they are orbiting. It was Huygens who eventually found with a little better telescope that it's actually a ring. And today we know that it's a ring of icy material, frozen water, and many other things which forms around Saturn. So a few more objects that I could show in the time that I have, and you might be remembering there was comet Neowise. It's a comet that visited some couple of years back, or even less than a little more than a year back. So the date is here, 24th of July 2020. And I had a very hard time seeing this because it was very close to the horizon. And the telescope was not good enough to see it because the illumination conditions were not suitable. To make it worse, the Chennai sky has a lot of scattering. And the interesting thing about a comet is its tail. If you don't see the tail, you can't know it's a comet. So I just wanted to show that there are other approaches one can adopt. You don't have to have a telescope. In fact, a long exposure camera can be a better way of photographing a comet rather than a telescope. So I made some attempts which gave a very faint tail. And my friends told me in Chennai that nobody else was able to see a tail in the city. You had to drive outside, but being the lockdown time, nobody drove outside. So whatever best was possible was with a long exposure camera. And so using this Canon SLR for a 30-second exposure, a faint tail could be captured. And this tail consists of, again, icy material, also different kinds of gases which are frozen. They start to vaporize when the comet comes very close to the sun. And if you go out in the rural countryside or in the hills, such as the ones you are currently studying in, you should be able to see much more beautiful view of the comets. Okay, the last thing that I would like to show you is about the pole star. And this picture shows you how to identify the pole star. It's very difficult to see in the kind of lower latitudes that we are in, very close to the equator. It's very hard to see. But you can take the projection of these two stars, which form the Great Bear or Ursa Major. And if you project them, you will find that that points to Polaris or the pole star. So pole star is the star which is aligned with the axis of the Earth about which it is rotating. I have not taken any good pictures of stars going around pole star because you need to be in somewhat temperate locations. You need to travel to, say, Europe or somewhat northern latitudes where you can get such nice pictures as this one. Long exposure would show you that the pole star remains fixed because that is pointing to along the axis of rotation of the Earth, whereas all the other stars appear to go around. So a long exposure of several hours will capture this, and pole star sits out here. There is an interesting thing about pole star that I would like to tell you, and that has to do with this analogy that the Earth is like a spinning top. Now, we are all familiar with spinning tops. Many of us would have played with it during our childhood. Why is the Earth like a spinning top? Of course, it goes around this axis, but that's not all. If you remember the spinning top, it undergoes many interesting motion. In fact, I would like to show you a few of these. And to do that, I will again minimize my presentation. And let me give a try. So I have this top with me, and if you wish, you could probably pin my screen so that you're able to see a complete view. So here is a top that I'm going to set up. Okay. So please observe the motion of this top. I will discuss about it shortly. It's undergoing rapid spinning and there is a precession motion. And apart from precession, you might see that for a brief time, this axis is actually becoming more vertical. It's getting a little more vertical, eventually will fall down. I hope you were able to see it. Can I have some feedback? Were you able to see this?
Yes, sir, we were able to see that.
Oh,
thank you.
So let me put the screen back. And then I'll explain to you how this connects with the motion of the Earth. So this top has many kinds of motion. It has rotation, precession, and nutation. There is precession happening, and the axis of precession is slowly changing. It's also going against gravity, so that is called as nutation. That is, gravity likes to pull it down, but while executing its motion, the center of mass can lift up. And it can also go down. So there are these different motions of a top, very complicated. And what this is called as is a heavy symmetric top. It's heavy symmetric because, first of all, there is an axis about which there is symmetry, and this is the symmetry axis. It's heavy because gravity plays an important role. You put it on some pivot, then the center of mass and pivot are separated from each other. So gravity induces a torque, and that torque is important in the complex motion that it undergoes. Similarly, the Earth is actually not spherical, but something like this. It is flat at the poles. This is an exaggeration. So the Earth is not like a spherical ball, but a little bit like what I'm showing you, a tomato timer, slightly compressed at the tops. As a result of which, when you consider the gravitational force of the sun and the moon on this tilted Earth, the Earth is not only flat, it's also tilted about its axis. With that kind of tilt, the forces exerted by the sun and the moon cause a torque. And if you write the Lagrangian, or if you write the potential as a function of this theta angle, it is actually quite similar to what is there for the top. Now the functional form is slightly different, but the physics is the same. And which means that the Earth also undergoes various kinds of precession. And there is this famous thing called precession of the equinoxes. The North Pole is not a fixed star. It keeps changing. 20,000 years ago, something else was the North Pole. Over a period of time, as this process is cyclic. So which star is the North Pole returns back. So our current North Pole will again become the North Pole after some 20 to 30,000 years. In between, the axis of the Earth will slightly change for reasons which are very close to what is shown in this picture. The Earth is in some ways resembling this heavy symmetric top. And apart from this reason, there are other reasons also that the Earth has gravitational forces from Jupiter and other heavy planets. All these factors put together are collectively held responsible for ice ages, when great regions of the Earth in the past, for instance, the whole of Europe was covered with ice. You had very different kinds of animals like mammoths or saber-toothed cats living there. So this is a periodic cycle, and this has to do with the physics of the motion of the rotating top. So I've come to the conclusion of what I wanted to share with you, and the title of my talk was Starry Nights. I borrowed this Starry Nights from the brilliant view painted by Vincent van Gogh in 1889. So when he was at this nice location with the stars and the lights of the city reflecting in the lake. I'll show you one last picture to conclude my presentation and talk. And you might wonder where this has been seen, which kind of stars or planets are shown here. What about the colors? And the stars look a little bit strange. So this is not, I'm sure you're not able to guess it, except one of you who knows the answer. This is Starry Night with Graphene, and it's work done by Ligin when he did his PhD at IIT Madras. He grew these structures which are quite resembling things you see in the sky. And these are monolayer of graphene. So that's my research area, about which I did not talk about till now, but except on this last slide. So Ligin grew these structures which are single atom thin. Each of this star is one atom thin layer of this material called graphene. Graphene is one layer of graphite. So all of you are familiar with graphite. You peel out one layer and you can, if you grow it by chemical vapor deposition, you can create this beautiful stars which are on this background of a metal surface. So this light color is a copper metal, and this black color is your graphene stars. I looked at these two pictures and I felt that there is some artistic connection, even though there is not much physics connection. There is some artistic connection. I thought of having it as the last slide of my talk here. So thank you for this invitation, and thank you for your attention. And I look forward to any questions if you have.
Thank you, sir, for a nice discussion. And a lot of insights are there in your talk. So new things we will learn from this talk.